Okay. Hi, everyone. Good morning and welcome to this session on Cairo Hands-On Workshop. So this session is brought to you by the Phoenix Guild and Starkware in collaboration. The Phoenix Guild is a community where we are trying to solve this problem of diversity and inclusion in the Web3 space. And as you can see here, here are like some statistics on the number of women, non-binary folks that are there in the Web3 ecosystem. Some of these statistics largely come from Western countries like Europe and America, because that's where there is some surveys happening. But in large parts of Southeast Asia, Asia, Africa, there are not even enough surveys to understand how the ecosystem is like. And the number of women, non-binary folks are very, very less. So this is a problem statement that we started out to tackle. And then we sort of built Phoenix Guild to tackle this problem statement by providing certain resources, mentorship, and educational initiatives for people in the ecosystem. So education and mentorship, where we do global workshops and bootcamps such as this, creating inclusive events. We try to keep our events in a way that, more and more people feel like coming and attending those events, very beginner friendly, or just in general having, an environment which is inclusive and supportive. Mentorship to leaders at regional hubs to scale our communities, as well as different opportunities that we try to provide them, where we help you contribute to open source, etc. Our mission and vision is to create and onboard the next million female and non-binary builders in Web3. And we want more and more people to recognize that, at leadership level, there needs to be inclusivity and diversity. So more and more senior positions need to be filled and have a balance. So here is some work that we have done in the past so far. We have run a bunch of Solidity boot camps, Rust boot camps. We have run JavaScript boot camps. We have run the FVM Roadshow. Now we are working with Starknet, Starkware, that's my team. And we have done a bunch of hacker houses as well, in India as well as across the globe. So been an exciting year so far, and we have a lot of exciting things planned in the future as well. I'll share with you shortly. We are doing a couple of boot camps as a part of summer camp with the Phoenix Guild, where we'll focus on learning basic Web3 skills as well as some interesting intermediate skills like Rust, etc. So if you're interested, I will share the registration forms to those as well. These are some of our partners we have worked as well. Today's session is largely, of course, sponsored by Starkware. The core team has 4 women, Nivedita, Gyan Lakshmi, that's me, Sri Lakshmi and Sneha. And put together, we have mixed skills that help us make this initiative a success. So that's a short introduction to what is the Phoenix Guild. For today's session, I'm going to split the session because it's a 2-hour session. I'm going to split the session into 2 sections. The first one is going to be about 30 to 45 minutes, which is going to be an introduction to Cairo. What is Cairo, the programming language Cairo, etc. And the second section of this would be live coding, where we will be coding a simple contract, which is the voting contract, live together. So for the second, why I've designed this program like this is because the second half will sort of give you more time to get your setups ready in the first half, because the setup is required to compile and interact with your second half contract that you will deploy. So before I start with an introduction to Cairo, I want to understand a little bit in terms of how many of you are already familiar with Starknet, and if you're already contributing to any Starknet projects, or like, do you want me to do like a Starknet 101 very quickly, or should we get started with Cairo? Can I just get like a show of hands or something on the chat if you are familiar with Starknet, or shall we directly just jump into programming and you want to do like a Starknet 101 later? Can I get some answers on the chat, please? Okay, a brief Starknet 101 will be helpful. Kaustav says, okay, Saurabh is familiar. I know Ram Kumar is familiar. So Ram Kumar, you have previously attended this session. So if you just want to come back for the live coding in the second half also, that's fine. Okay. How about others? Ananya, Naresh, are you familiar or okay. So Kaustav, just in the interest of time, okay, 101 would be helpful. Okay. Now I have two. Okay. Okay. So let me do like a very, very quick 101. I know for those of you who are already on this call who are familiar with it, please bear with me. I will try to take just like 5 minutes or something and try to very quickly do this. Naresh and okay, so Ananya as well. Okay, Naresh, Ananya, and Cost. So most importantly for you guys, are you able to see the screen? Is the screen visible? Yep. Okay. Okay. All right. Let's go. So this is okay. Yeah. Just a quick introduction about myself. Yeah, Ashna as well. Okay. So just a quick introduction about myself. My name is Gyan, also Gyan Lakshmi, and I'm based in India. I'm a developer advocate with Starkware, largely on Starknet, and I'm passionate about diversity in education. So we together co-founded the Phoenix Guild earlier last year to help more women and non-binary folks come into the ecosystem, right? I'm going to very quickly do like what is the need to have something like a what is the need to learn a provable programming language like Cairo. So think of this in a way that if you are a space scientist and you are participating, you have to build a space exploration program. Then you'll have to think of some parameters as to how to save fuel, what is the best launch window, trajectory, etc. And as an engineer, you will build an algorithm and write something in a general purpose programming language like Rust. Now, when you write this general purpose programming language, here you have a problem statement that this execution is so huge that you need a supercomputer to perform this execution, and only your rival country has one, right? So what happens in a typical scenario is that you give your program to the supercomputer, it will execute and it will give you a result. But in case the supercomputer malfunctioned or somebody else tampered with the supercomputer, there's no way for you to trust this supercomputer. However, if you use a programming language like Cairo, which is called a provable programming language, when you send this programming language to this supercomputer, it will not just produce a result, but it will also produce a proof. And this is what makes Cairo different from other programming languages, that Cairo helps you write programs that can generate a proof that this particular computation was successful. So the underlying mathematics behind this is called or generates from something called as computational integrity, CI, where you have to prove that a certain computation happened, right? And the idea of zero knowledge proofs is the fact that you can prove that certain computation happened without actually having to reveal the parameters of that computation. So what programming languages like Cairo does is that it allows you to keep a regular computer, it allows a regular computer to keep a supercomputer honest. So why Cairo? Because it helps you create provable programs. A cryptographic proof is generated alongside the result. Proof verification can detect cheating or malfunctioning without re-execution. And then a regular computer is able to keep a supercomputer honest. For those of you who joined very recently, if you're here for the coding section, we are going to do that in the second half. This is a 2-hour workshop. So we are going to do a 45-minute introduction to Cairo, where we will explain all the features of Cairo. And the second half of the workshop, we will live code a contract called the voting contract. I will share the gist of the contract with you, which has incomplete functions, and we will complete the functions together. So we'll do 45 minutes of presentation, a little bit introduction to Cairo, features of Cairo, and then 15 minutes break, and then 45 minutes of live coding. So I've shared a setup doc, which is a Google document link. please make sure to set up your environment so that you can compile and execute your, interact with your programs on testnet. And if possible, also create an account and keep it ready. Actually, for the voting contract, you will need to create 4 accounts. One will be an admin account and 3 accounts will be used for testing the voting contract. So please create 4 accounts on testnet, on CLI, and keep it ready. I will also give you the instructions during the break. Now I'm doing a quick 101 for those who are completely new to Starknet. This is just going to be a quick 5-minute thing. So why is Starknet and what is the problem that it solves? I'm assuming that most of you are already familiar with the Ethereum ecosystem. And for that matter, most of the L1s kind of function in a similar way. So in Ethereum, you have the concept of validators, which validate that a particular execution was correct, right? So, and then they produce, whenever a block is produced, where there is a state change, that is, think of the value of a variable change from 0 to 42. So the new state is 42. Now, all of these validators will actually have to re-execute this to make sure that, yes, this particular state change is correct, right? What if the variable is not allowed to have the value 42? Then this particular block is actually not right, right? So to make sure that this is true, all of these validators will re-execute this entire thing. Now, in Starknet, where it's a layer 2 solution built on top of a layer 1, which is Ethereum right now, which allows you to not just produce a block, right? But also allows you to produce a proof. What is this proof? This is the proof that this particular computation that was done to affect this state change is correct, right? So these proofs that are generated are called validity proofs. They check the validity of a particular computation. That is, this particular, in order to reach the state 42, you would have to go through some set of computation, right? You would have to check whether this variable is this, and then there'll be some things happening at the compiler level, etc. And then final result is 42. But apart from the result, if you remember from the previous slide, there is also a small proof that is generated. This proof says that the computation has been performed correctly. So this is a valid proof. That means that's why it's called a validity proof. And Starknet is called a validity rollup. I'll come to that as well. So now that there is a proof that is already generated, the validators don't have to re-execute the entire computation. They will just have to verify that the proof is correct. So every proving system has 2 parties. There is a prover and a verifier. So here, what are we trying to prove? That this particular set of transactions that have been executed and have been added to a block, we are trying to prove that this computation that exists as a part of that transaction is true, right? That is, we are trying to prove the computational integrity. And the validators here will be, all they have to do is just verify the proof. So the time taken for the validators to verify the proof is much, much lesser than the time that is taken for them to re-execute the entire computation. And this is how Starknet helps in scaling Ethereum. So it's an Ethereum scalability solution. It's a layer 2 validity rollup. It uses the principles of proof generation, and it uses the algorithm called STARKs, STARK, Scalable Transparent Arguments of Knowledge. So here is a simple sort of, a graph that helps you understand this better. That is the amount of time that is taken to compute the transactions, right? Where you are going to compute the execution, where you are going to do this transaction computation, compared to the amount of time that it takes for verification is much, much lesser. So this linear graph is actually showing that this is the work done in order to compute the transaction, whereas the logarithmic graph, this is the polylogarithmic graph that shows that log square of n is the amount of time that is used for verification. So it takes much lesser time to verify this, and thereby helping you scale Ethereum in a good manner. And then also the T, which is the transparency part, comes from the fact that there is no trusted setup required for Starks. So validity proofs, which is what Starknet is based on, is equivalent to compressing the computation into a small proof. And you can think of an analogy like compressing a file size to create like a zip folder, right, in order to make it more scalable. So what are validity proofs? Validity proofs are an implementation of zero knowledge proofs. Zero knowledge proofs uses the concept of a prover and a verifier, wherein a prover tries to prove that they have done some computation with integrity. So they are trying to prove computational integrity. And the verifier is trying to verify if this computation is correct without actually having the sensitive information associated with that computation. That is the definition of zero knowledge proofs. But validity proofs are an implementation of zero knowledge proofs. They are not completely zero knowledge because Starknet is a public L2. So what do validity proofs do? They use the ZK proofs to guarantee computational integrity. That what does it mean? Doing the right thing even when no one is looking. And Starknet is not just about privacy, it's about scaling. Starknet has been built with the idea of having a performance improvement in executing transactions on Ethereum. So that's why even our VM, which is the Cairo VM, focuses more on performance, right? So anything that you can build on Ethereum, you can build on Starknet. So it's not just about privacy, it's about scaling. And the name ZK rollup is a misnomer because it's not completely zero knowledge, as I mentioned. Starknet is a validity rollup. And Starknet uses the algorithm Starks, but not the SNARKs. Okay. So this is a quick comparison for those of you who are interested. The verification time taken by Starks and the proof size is higher as compared to SNARKs. But what is better is that there is no trusted setup. That's why you see the T for transparency. It is transparent right from the get-go because you don't require any trusted setups. You don't need to generate additional parameters to be able to generate Stark proofs. And it is post-quantum secure or quantum secure because it does not depend on elliptic curve cryptography. One of the sort of mathematical assumptions and underlying assumptions in Stark math is that it depends on collision resistant hashes, which are for now post-quantum secure. So I'm going to stop here and just see if there are any questions before we dive into the Cairo section. So for those of you who are fairly new or who are joining this for the first time, do you have any questions on Starknet and like anything that you have in mind? I know I did a very quick intro because I want to keep the time in mind, but if you have any questions, feel free to ask. So Ananya requested for a 101, Naresh requested for a 101, Kaustav. Yeah. Do you folks have any questions for those of you who requested for a quick 101? No. Okay. Okay, great. All right. So that's perfect. Okay, no questions. All right. Okay. So then let me directly dive deep into let's get started with Cairo. Okay, so I don't generally use a presentation for Cairo because I don't have like a programming language presentation. So I'm going to use this resource called the Starknet book, which also I'm going to share with you. And I'm going to use this parent repo. Oh no, let's do the example. Okay. So these are the two things that I'm going to be using. Both of these are open source repositories. So you can also just check them out whenever. Okay, so this is called the Starknet book. This is a book that we have been working on from the education team, and it has more or less almost everything about Starknet. You can see some of the chapters, sorry, it has more or less, yeah, everything about Starknet in Cairo. You can see some of the chapters are under construction, this symbol. That means you can still contribute to these chapters. There are a couple of other links as well. There is Cairo official docs. There is a Cairo Lang book, which has been created by the community. That's also very, very nice. I personally recommend a lot of people to, go through the Cairo Lang book. It's like this. It is similar to Rust Lang book, if you might have seen it. It has more in detail to what we have in our Starknet book. That's why I'm not going to go into this today because it might be a little overwhelming for those of you who are new. But this is a good enough, like really good place to get started with Cairo. So basically, Cairo is a strongly typed programming language similar to Rust. So a lot of constructs that Rust has, you will find those similar constructs in Cairo. For example, traits and implementation is something that was introduced in Rust, lately got popular in Rust rather. And you can kind of take the same principles from there. And then macros is also a very interesting principle that is used here. And arrays, spans, and snapshots is again an interesting concept from Rust that has been taken here. There are certain things that are still under sort of construction, so please bear with me. Cairo. So this version of Cairo is called Cairo 1, and this was recently released towards mid-March, end of March, third week of March. So it's very, very new. And that means we are looking for a lot of contribution from people as well. So if you just experiment a few contracts and decide that there are some sections where you want to contribute, then I highly encourage you to do that. As you can see, like this book is also open source and open for contributions. So because it has to be strongly typed, because every provable programming language, largely the circuits or the arithmetic constraints that are part of this provable programming language will need to ensure that these do not fail, right? So it has to be a safe programming language. So that's why Cairo compiles to another I wouldn't say language, an intermediate representation called Sierra. It's called Safe Intermediate Representation. I will show you that when we talk about the compilation workflow. And from Sierra, it compiles to something called CASM, CASM, which is short for Cairo Assembly. And Cairo Assembly is the one that is actually deployed on Starknet. So because it is a strongly typed language, which means that every variable, constant, and function argument must have an explicit type. Please remember this while you are writing your programs. Sometimes it will create issues if you have not explicitly specified a type for a variable. It may get confused and stuff like that. So this enforces strict type checking, providing increased safety and reduced likelihood of runtime errors. So this particular Cairo one has a rich type system. I'm not going to read that out. I'm just going to show you the different primitive types. So you have U8, U size. Basically, you have U8 to U256. And there is a U size, which is an unsigned size integer where which you typically use for, expressing lengths of an array and, indices, etc. And then you have Boolean, which is bool, which can be either true or false. Felt 252 is a, maybe if you are not familiar with Cairo, this might be a new type of element for you. This is called as a field element. So the mathematics behind Starks uses something called finite fields, and because this mathematics is now represented in the computer science format, this variable also needs to be represented in as a computer science variable. That's why you have felt 252, which represents 252 bits. And then for address type, if you're from Solidity, then you have contract address, which is a type representing a Starknet contract address, used for identifying and interacting with smart contracts. Okay, new person has joined, Mehul. Mehul, I'm going to just quickly send this setup doc to you. And here is the references that we are looking at right now. We are just doing an introduction to Cairo. So there is also generics, which can be used with, if you want to use generics, you can use the variable t, which represents a generic type placeholder, which can be replaced with any specific type during compilation. So this is one cool thing that this Cairo supports generics. That means you can have multiple different types, and you can, decide during compile time what type of element, or what data type you want to have over there. Then you have this other cool thing called option. So option is actually, generally, if you are doubtful whether a variable will result in a null value, or whether it will have a value or not. So for those things, option might be really helpful. And of course, it can be applied to any data type. That's what is the generic one. There's a generic here, which represents a value that may or may not be present. So you can use this largely for error handling. Sometimes you expect that some value will be populated in this variable, but it may not. So that time you can have that variable type to be an option variable, option type of variable. Then you have another type called result, which represents the outcome of a computation that may result in an error, used for error handling and control flow again. Then for arrays, you can have arrays of different types. So here you can, like, basically you have a dynamic array data structure for elements of type T, used for creating and manipulating arrays. So spans are also something that stem from arrays, where you can use spans for accessing different array elements, right? But you cannot manipulate them. And similarly, you have snapshot as well, which I will also talk about very quickly. So for those of you who are completely new to Cairo, I want to also show you this example, that example repository that my team has put together. And you can find this on the Cairo core repository itself. So generally, most of the Cairo contracts, we use the Fibonacci series as an example. That's because Fibonacci series, has everything in it. You can use recursion, you can have, you have complex mathematics and computations, etc. Also, it seems like it is the choice of engineers from my team who wrote Cairo. So, uh, okay. So you can, let's take a look at this very simple sort of small Fibonacci code, which shows how a Cairo function is written. So this function, so you use the keyword fn, which is the keyword for defining a function. And the name of the function is fib, right? So you are going to take two variables. That is the first you always, okay, is everyone familiar with what is a Fibonacci series? Yes? No? Can you place it on the chat? Mhm. Okay. Yes. Yes. Okay. Largely yes. Okay. So for those of you who are not familiar, Fibonacci series looks something like this. This the upcoming element is the sum of the previous two elements. And the first two elements are 0 and 1. So this is how a Fibonacci looks. Okay, so here you are taking the first two elements. You are taking A, which is 0. You are taking B, which is 1. And then you are taking how many number of elements in this Fibonacci series do you want to return? Or which nth number do you want to return, right? Because we are only returning one felt 252, not an array. So here is the variable name, colon, type of the variable. So here is another variable name, colon, type of the variable, and then which is the number, which is the nth element in the Fibonacci series, and then type of the variable. And then when we want to return a variable, we have between the return variable and the arguments, we have an arrow followed by that. What is the type of the variable that we want to return? So this particular piece of code actually uses recursion. So there is a statement called match. Match is something similar to switch case, if you are familiar with C++. What this does is this matches the value that is present inside this variable, that is n. So if n is 0, right, this is what it is saying. If the value of n is 0, then directly return A, because you are just returning the 0th element of the Fibonacci series. Okay, there is a question. How to convert U8 to U128? So if you want to convert, then you will have to typecast. Let me check how that is being done. And if right now Cairo does even support typecasting. So I'll have to check that. Okay. So right now you're taking, what is it doing? It matches the value of n. If it is 0, it directly returns A because that's the 0th element. And if it is any other element, it basically returns Fibonacci of it's just recursively calling this function. So B becomes A, that is your second element becomes the first element. Your new element becomes the sum of A and B. And then your number of, now the number of elements that you need to calculate has been reduced by 1, right? So earlier you had to calculate 8, for example, then you are doing only 7, then you are doing 6, 5, 4, 3, 2, 1. Okay. Okay. After the new version, it is failing for you. Okay. Okay. I haven't tried the RC0 version, but let's try. We can try it out during the hands-on coding. So yeah. Okay. So here, this is a recursive call. Right. So loops has been recently introduced in Cairo 1, and it will be implemented soon. But largely, until loops was introduced, we used to depend on recursion. And that's why you see a lot of programs will have recursion as an example. So this is a simple sort of how do you calculate the nth Fibonacci number? And when the n becomes finally, comes to 0, it will return the last number. That is the number that you're looking for, 7th number, 8th number, or whatever. So this is a straightforward, simple example. And you can see that the different data types that were there in the example was only felt 252, but Cairo 1 supports all the other data types as well. For example, here we have another function called an example function. This takes in a value of type U32, and then it doubles the same value by multiplying into 2. Now, there are two things that you need to notice here. One is this new variable called double value also has been explicitly assigned a data type. So whenever you have to assign a data type, you can use this colon and assign a data type to this value. Otherwise, it will be confusing. And also remember that Cairo is a programming language that uses very strict type checking. So it is always best practice to assign a data type so the compiler doesn't get confused. And here you are seeing 2 written in a different way, right? It's not just value into 2. That is because you need to typecast this 2 into U32. U32. Your value is of type U32. All the variables by default in Cairo are of type felt 252, which is the field element type, because Cairo is built on top of this mathematical, constraints. So that's why you have 2_U32. And so now it is every number or every integer literal, you will have to, whenever you are say adding, multiplying, subtracting, or whatever, you will have to convert it into that particular data type, right? So value into 2_U32, and then you return this value. So here in this example, value and double value are explicitly typed as U32, and the function has a return type of U32. This ensures that the types are correctly enforced. Yeah, okay. Yes, typecasting. So typecasting is basically you are saying that it is of type felt 252, but you are actually casting it to type _U32. Okay, good. So now typing integer literals. So this is the way you typecast the integer literals. So you can see you use an underscore followed by the desired type, like this. Okay. Now I'm going to quickly go through the functions and the modules chapter. So if you see, it's very simple again. The functions, I told you the keyword is called fn, followed by name of the function. And then you have open close parenthesis within which you can take in the number of arguments. And the number of arguments, the argument list is comma separated. So you will write the value, you'll write the name of the argument, colon, the type of the argument. So this is currently not taking any arguments. And then it's separated by an arrow. You will return, you can have the return type. So if you're going to return multiple types, then you can put them in this parenthesis, separated, comma separated, right? And then you have open close brackets. And here what are we doing is we are reading a particular variable by using : read. And similarly, if you want to write a particular variable, we can use : write. Now you see something called view on top of this function. These are called macros. So you can think of these macros as different attributes that are being given to this function based on the purpose of this function. So if the function is a constructor, then you have to add a constructor macro on top with #constructor. And if the function is just a view only function, that is you are just reading the value from the blockchain. You're not going to manipulate anything. You're not going to make any state changes. Then you can add the tag view. Yeah. And then there are external functions wherein when you add the tag external, that's when you can call this function from outside externally, and you can also manipulate the variables that are part of this function. Now, this is a simple function where we are reading two values and we are just returning them. So you can see we are returning two U8 values. So because if you come from Solidity background, you might have seen that there's function visibility like public, external, internal, private, etc. It's not explicitly specified in Cairo. Instead, functions are considered internal by default unless they are marked with a view or external attributes, right? So now the next thing in Cairo is modules. So when you want to group together related functionality, or you want to box a set of logic together, that's what we do in smart contracts, right? We bunch a set of logical statements together, which then, finally give us whatever result we want, etc. Now in the case of Cairo, these logical statements that are bunched together are put inside something called as a module. So a module is defined using the mod keyword, followed by the name of the module. So think of this as the contract keyword in Solidity followed by the name of the contract. But to indicate that this itself is a contract, you will have to add the macro contract on top to say that, yes, this is a contract module. Now, for example, here we are having a module called vote, which imports other modules like Starknet, array, to get the functionality from the other module. So these are some core libraries from where this is importing certain functionality that you want to use in your code. Here there's a quick comparison with Solidity where we use the FN keyword instead of function. Attributes, Cairo functions use attributes like constructor, view, and external. In Solidity, instead you use keywords like constructor, view, and public. And then return values in Cairo, return values are declared using the arrow syntax, while Solidity uses the returns keyword. Then for modules, you define the contracts using the mod keyword, while Solidity uses the contract keyword. And imports uses this keyword called use, if you might have noticed, and Solidity uses the import keyword itself, right? And then namespaces, Cairo modules serve as namespaces for related functionality, whereas in Solidity, the contracts themselves act as namespaces for function and variables. So here you have modules, there you have contracts, which act as namespaces. Okay. Structure of a Cairo smart contract. I'm going to skip this because we are going to do this in our hands-on part, right? So we have different imports. How do you use and write storage? So I want to quickly go over, let's say, writing storage, if we can. Okay, let's go to the contract example. Okay, little high level, but okay. Okay, so this is a simple account contract in Cairo, right? Don't worry about the complexity of this program. Actually, once you understand, in the second half, once you write your own program, you will easily able to understand this contract. So here we are using some imports. That is, we are importing functionality from other modules. Like we have a SED module for serialization, deserialization, Starknet module. We have an array module again here from where we are importing both array and spans. And then we have the option module. You remember the option data type. So we are importing some of these. Then this is a special type of contract called an account contract, because all accounts in Starknet by default are smart contracts. So we don't have the concept of externally owned accounts. It's all smart contracts. So all the wallets are also smart contract wallets. So here we have module, and then name of a module is account, right? Now, a couple of things that I want to show this you're already familiar with, importing. And then we have, whenever you want to store the variables within a contract into permanent storage, then you have to define a struct called storage. The name of the struct has to be storage. This is a structure. So structure is a data type which can have multiple data types within. So name of the structure should be storage. And within this, you can have different types, different data types, which you will be using throughout your contract. So here, the only data type that we use throughout our contract is public key. And the type of, so this is the name of the variable, colon, type of the variable, right? You can have multiple data types like this as well. And then we have a constructor. So constructor is a function again with the macro constructor. This is taking a data type. This is taking an argument called public key of data type fel252. And this is what I wanted to show, which is storage read and write. So you can write to storage using this function write. So you see colon, write. So the name of the variable, colon, write, and then the value of the variable that you want to write into. So this is, again, there are lots of different things happening. And then there is one other specific data type that I want to introduce you to, which is called map. So like, okay, let's just go to that. Let's go to this contract only. Okay. So here you have this data type called legacy map, which is similar to your hash map, right? So you have a mapping between two variables. That is, you have a mapping between a contract address and a Boolean. So this is a particular type called can vote. This mapping is called can. Name of the mapping is can vote. And this is a hash map where you have a mapping between a contract address and a Boolean. So can this contract address vote? There'll be true or false for every mapping. So you can see that there is a struct storage, which has all these different types of storage variables. So most importantly that, and then you have something called event functions that I've not covered yet. Is very simple again. Events are basically similar to your solidity concept, where it's something gets logged when you're trying to emit that event. So whenever you have to use an event, you have to use a macro like this. And events are also functions. So just like your external and internal, how you add the external and view, you can add the macro event on top of a function, name of the function, and the arguments that you're going to emit. And right now it is like empty because we just don't do anything else, but just emit the event. So how do you emit the event? You just write the name of the event within the, wherever you want to, say when the vote was cast. So in the voting function, we are saying vote cast, and then we have two arguments that we are emitting, which is caller and vote. So we are emitting the vote cast event after the vote has been processed. So this we will do in the next section. Then you have constants. So you can use the keyword const to define constants. So this is fairly easy. You can just use them as is like this. Right. And then what else? Yeah, traits and implementations is slightly more complex. I don't want to go through this because I feel like this might be a little overwhelming. But basically, think of traits as similar to interfaces, right? Traits serve as interface definitions, providing a blueprint for a set of methods that a contract should implement. So when you have generic contracts like ERC20, ERC721, or contracts that that certain methods that should definitely be a part of the contract. For example, in an ERC20, a safe transfer from, or something like approval, right? So these are certain functions that that this contract should implement. So in that case, you can write a trait which will have these interface definitions, and which provides a blueprint of the set of methods that a contract should implement. By defining a trait, you specify a group of related methods without providing any actual implementation, right? You can provide some default implementations if you want for traits, but you can also just leave them as is. So for example, to define a trait, you will use the trait keyword, and you are here defining a trait called voting result trait. So whenever any structure wants to use this voting result trait, they can use the functions that are, they will have to implement the functions that are coming along with this trait. That is a get voting result. So there are two functions defined in this trait. One is get voting result, and one is get voting result in percentage. So whichever structure implements this trait, like whichever entity implements this trait, they will have to also implement these functions. This trait requires any contract implementing it to provide two functions, get voting result and get voting result in percentage. So again, how do you implement a trait? It is also very, it is not super complicated, but just to give you like a brief idea. So here we are implementing a trait followed by the name of the implementing structure. So our implementing structure in this case is voting result IMPL, right? So you will say implement voting result IMPL of voting result trait. So you're adding the trait voting result onto this voting result IMPL, right? This is implementing this particular trait. And what does it do over here? That this has to now implement two functions, right? It has to implement both the functions. That is get voting result and get voting result in percentage. So I don't know what this inline always macro is, but I will check that out. But here, the simple thing is you're going to implement the two functions, get voting result. So you're implementing this function and you're writing some logic for it. And then get voting result in percentage, you're implementing this function, you're writing the logic for it and returning the percentage. So this is again, simple stuff. So you can, to call a trait function, you'll use the name of the trait like this, voting result trait, double colon, followed by the function name. And similarly over here, blah, blah, okay. That's it. You have now learned the basics of using traits in Cairo. So we will see this in our code as well. Okay. So what does a trait mean? Okay, there are two questions. Are modules like classes in C++? And what does a trait mean? Let me answer the second one first because we are on the trait page. So traits are like interfaces. So in a trait, you can define what and all are the functions that this particular contract should implement. For example, if you are writing your own ERC20 contract, you can implement a trait for your ERC20 contract saying that these are the functions that I will directly take from this particular trait to implement. Like how we have interfaces, which will have like, these are the set of methods that you have to implement. So you can encompass that into a trait and have it for yourself. And then you can take that and implement that trait within your contract. Let me see if there are more examples. Yeah, okay. Let's see another set of examples for defining the traits. For example, within a trait, here they are defining a trait called shape geometry. So shape geometry can have what and all functionalities. It can have a boundary, right? And it can have an area. So let's say, for example, that we have multiple structs representing shapes, and we want our application to be able to perform geometry operations on these shapes. We can define a generic trait called shape geometry that contains a blueprint to implement geometry operations like this. So boundary or area. So when you implement this trait, for example, if you have a rectangle for yourself and you say rectangle geometry of shape geometry, you will implement the boundary function and the area function according to the logic of the rectangle. Right now, don't worry about the self parameter. It is for like calling this like instant. It is for like, think of this as like calling an object, using an object to call a function, right? So, but yeah, so if, for example, here, if you, instead of rectangle, if you can have something like a square geometry, which will implement the boundary in a different way, and it will implement the area in a different way. Similarly, if you want to implement the same trait for a circle geometry, you can do that too. So traits are like, it will encompass some certain set of functions that this particular implementation must implement. And there is more complicated stuff like generic traits and all that, which we don't have to worry about. But hope this is clear. Okay. Okay. Are modules like classes in C++? Kind of, yes. But one thing is, I would say within modules, you can also have structs, right? So modules will have, so similar to your contracts, right? Modules will have a set of variables and functions within them, right? Which is what your classes are all about. It will have a set of variables for that class along with functions that act on those variables, right? So modules are similar, but modules can also have other type of data structure inside that, like struct. So which in itself is a data structure that encompasses a bunch of variables, right? So I would say kind of, yes, similar, but I don't know if classes can also have, I forgot C++, to be honest. So I don't know if classes in C++ can also have other complicated data structures inside them. Maybe they can. Yeah. Okay. Okay. Awesome. So this is like a very like simple kind of like overview of what Cairo is. Do you have any questions? Do we have any questions? If not, we can break for like few minutes, maybe 5-10 minutes, and then we can come back for the hands-on coding session. Okay. Yeah, they can, I guess. Yeah, even I think they can, but I've just forgotten C++ altogether. Okay. If there are no questions, then let's take like a small 10-minute break, and we will come back again at 12:10. Is that good? Shall we meet at 12:10? Yeah, Saurabh, yeah, please set up Cairo if you have not yet set up. And if you need Cairo, sorry, Saurabh, what help do you need in setting up Cairo? Yeah, for those of you who have already set up, we'll take a break. And then we stop.